It's Taco Tuesday. All right. So what is the domain of this function? What's my farthest to the right value? Look again. This is a 2. This is a 6. It's like 5. Okay. And then how far to the left does it go?
5.
Oh my God. Domain, guys. Negative infinity.
Oh.
Negative infinity. That is white. I can't do that. All right. There we go. Negative infinity to 5. Now, compare it to the domain of the parent function. Do you remember the parent function? God. Square root of x. That's the parent function. That's the OG. No, nobody laughed. Okay, it's the original gangster. All right. So the domain for this guy, if you remember, we graphed it, it would be like this. Yeah. So that would be from 0 to positive infinity. So how do these compare? What do they do? Between these two, how do they compare? Okay, so one of them is reflected across the y-axis, and then we move to the right 5. What was that? So let's read it over. Water is draining from a tank. Oh no, connected to 2 pipes. Okay, so on your paper, I would say example 1. And I would draw a lovely picture of a tank and then 2 pipes coming out. Where are y'all's passes? Where have you been? Okay, so the speed F in feet per second at which a water drains through the first pipe. Talking about the first pipe. We're gonna name this guy first. Okay. Can be modeled by this equation where X is the depth of water in the tank. So I would write down X is the depth of water in the tank. Okay, and then I would also write down that speed is feet per second. And then I would write probably the equation down. And when you like make notes of these, I'm not asking you to write down every single word. I don't want you to write down the scenario entirely. I want you to make bullet points. Yeah, roughly. Don't look at me like I'm crazy. So what is the domain of this function? That's what we're trying to answer. So I'm gonna give you a second to finish writing down the instruction. So domain in context. Okay, so domain is our x values, right? And we're talking about the depth of the water. Okay, so that's what we're talking about. How high is the water when we start? And how can you tell? How high is the water when we start?
4.
Not 4. How Ellen said it. 64. Ellen, where did you get 64 from? From the equation. Okay, so the highest that it can get is 64. Now, have you ever taken like a bowl and like cut like if you cut pieces out, like 2 holes in it, once you drain all the water, wouldn't it be like a little puddle of water in the middle? Okay, so that would be this x value right here, right? Which would be what number? Not 4, 2. Where'd you get that from? The equation. So our domain is going to be 2 to 64. Everybody see where I got that from? Okay, you could also look at the graph, and if you plot this in Desmos, this would tell you that it was 2. However, this would continue on. It wouldn't stop at 64. You would have to use the fact that it's in the equation to help you with that. 2 represents the lowest amount of water in the tank. So interpret the domain in context. So 2 is the lowest amount of water. And 64 is the starting amount. Yeah, because we start with 64 and then it drains, right? Because remember, we want to put this in context. We don't just want to state numbers and then not have any reasoning behind it. Okay. Justin's physics textbook states that the speed s in meters is spelled wrong, per second. So sorry. meters per second of sound in dry air is related to air temperature. Okay, and we're dealing with Celsius, and here's my equation. Okay, identify the transformations as compared to this. This is a question that you will see often. Okay, they'll always give you some bizarre equation, and then they'll say, hey, relate it back to this equation. Okay, so what I need you to do is write down this equation. Say speed is S in meters per second, and P is degrees Celsius. So take a second. This is example 2. Write those things down, and then we're going to discuss those. Okay, identify the transformations as compared to this guy. All right, so the first thing I always do is I take the original function and then kind of like highlight it in my equation, right? Okay, so this 20 that's chilling out front, what does that do to the equation? 20 that's chilling out front.
It
It multiplies, but that's like our A term, right? What does our A term do? Stretches it. Oh, okay, good. All right, so a stretch of 20. Okay. All right, so we got that stuff out front. On the inside, we got a plus 273. Remember, the junk on the inside moves left or right. Okay. And in this case, we have a plus 273. So that means that we're going to move left 273. Okay. If you're like, how the heck did she do that? 1, magic. 2, also, remember, we wrote this equation down. I think it was like Friday. And we talked about how A was the stretch or shrink, H was left or right, and K was up or down, right? We okay on that? Okay, now let's determine our domain and range. Okay, so most of the time you can do this by plugging into your calculator and then looking at the graph. You can do that if you want, okay? We're actually gonna look at it just to kind of help us. But we know that 273 is going to deal with our domain. And we know that this is facing positively, right? Okay, so maybe I'm not going to put this in the decimal. So we know that it's going from negative 273, and then it's facing upwards, right? So what's our leftmost X value? Negative 273, right? And then how far to the right do we go? Yes and no. You can't be like infinitely high. Does that make sense? Like think about the sun. The sun reaches a certain temperature, right? Like it really doesn't go over that temperature, right? Or it will explode. Okay, so this one kind of is a weird question to ask because they don't give us enough information to give a correct right answer. We're gonna say infinity right now. However, this probably would be about 273 degrees Celsius, roughly. Now your range, our lowest Y value is going to be 0. And then again, they really didn't give us a whole lot of information to help us like determine the right side, because speed doesn't just go on forever. Like you don't reach infinitely speed. Does that make sense? So it would probably be something related to 273. Right now we're going to put infinity, but this would probably be about, like if we plugged in 273, whatever that is, like 2 square root of 546. Again, they would probably give you a little bit more information. Let's talk through what you would write down. A manufacturer wants to predict the consumer interest in a new smartphone. Company uses this function, so I would write the function down, right? And then to model the number P in millions, that's going to be important, of pre-orders. And then D is the number of days before the phone's release date. Okay, so I would write everything that's kind of circled or underlined in pink. Now, identify the transformations represented by the function as compared to the square root of D. Very similar to that question that we just had. Now, pay attention closely because we have transformations going on and we got a bunch of them, right? So the first thing that we notice is this negative that's out front. So what does that automatically do to something? Reflects across the x-axis. Okay. The 2 right here does what? Stretches, right? Remember, if it's bigger than 1, it's going to stretch. Ignore the negative, right? A stretch of 2. You do have this negative underneath the radical. What does that do? Not imaginary. It reflects it across the what? Y-axis. So reflects across the y-axis. And then the 20 out here does what? It's not underneath the radical, it's outside. So it's going to move it up 20. What's up? About domain and range. Okay. The domain is going to be my x values, right? And that's going to be from, all right. So the domain is going to be from negative, we can say infinity, but we probably don't want to look at that. We probably want to look at something a little bit closer. We're going to say negative 35-ish. And then how far to the right does the x values go? Nope. Look again. 0. Okay. Now for range. Okay. For range, what's the lowest y value? Well, remember, our y values represents the number of pre-orders, right? Yeah. So let's think about it. If nobody orders any pre-orders, how many are we going to have? Okay. If somebody actually orders it, how many can we sell in total? 20, and that's in millions, just a heads up. Okay. Now remember, domain is going to represent the number of days before the release date. Range is going to represent the number of pre-orders. So on part C, it says determine the number of pre-orders that the manufacturer can expect to have 30 days before the release date. Okay, now I need you to bear with me. Here's the formula right here. Okay. If we plugged in just 30 into our equation, it's going to give us a negative underneath the radical. That's a no bueno, right? Now, we're going to plug in negative 30 because it's before the release date. Release date is 0, right? And we want negative 30, right? So we're going to plug that in to our equation. Negative 30. And then plus 20. So this is going to give me negative 2 square root of positive 30 plus 20. And if we plug this into our calculator, we're going to get about, I think it's about like 2, 4, 6, 8. It's like 9-ish million, something around there. Somebody correct me if I'm wrong. Like 9-ish. Yeah. Okay, so 9 million pre-orders. All right, on Earth, the distance d in kilometers that one can see on the horizon of altitude A, so A is altitude in meters, can be found using this. Okay, so go ahead and write down this equation. Go ahead and make sure that you write down what altitude is, and then distance in kilometers. To find the corresponding distance to the horizon on Mars, the function must be stretched horizontally. Okay, what you need to do is write down this statement, stretched horizontally by a factor of 9/5, because this is the one different piece that we have not talked about yet. All right, it says if someone is at an altitude of 100 meters, what is the distance to the horizon on Earth? What is the distance to the horizon on Mars? Okay, So on the first question, it's talking about this equation, right? So we're going to take 3.56 and we're going to square root 100, right? And so that's going to give me 35.6 kilometers, right? All I did was I plugged in the 100 in for altitude. Now, what they want to do is they want us to take the equation for Earth, but we're going to stretch it horizontally, right? We're going to stretch it horizontally. So what you're going to do is write down the equation. And on the inside, you are going to flip this fraction and put it on the inside. So if they say stretched horizontally, you're going to flip whatever the fraction is and put it on the inside. Hey, don't put it back. Put it back. Okay. So now we're going to plug in 100 into this equation. So we're going to get 3.56 times 5 times 100 divided by 9. And if somebody could plug that into their calculator and tell me what it is. 3.56 times 500, I'm sorry, times the square root of 500 divided by 9. What is it? 2.6?
Yeah.
At least 4.
Drake, what'd you get? Okay. That sounds about right. All right. Now, sometimes they'll say stretch vertically. If they say stretch vertically, you're just going to take the number and put it on the outside. But since they said horizontal, it goes on the inside and it flips. This is the only weird thing. You have to look for this word for you to do that. What? Yeah. If you do vertical stretching, then you're just going to take whatever the number is. Let's say it's 9/5, and it's just going to chill out in the front of the radical. Good.